Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETAS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETAS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Hello everyone, thanks for your time again. Here's Marcos Cardoso and we are having now one more podcast about fuzzing. So as I said, my name is Marcos Cardoso. I'm product manager in ETAS. I'm a product manager of protocol fuzzer tool called Fuzz, and I work since 2004 in the test and measurement industry. And today I have the pleasure to invite our special guest, Seungtaek from Keysight. Hi Seungtaek, can you introduce yourself please?
Thanks. Hello, everyone. My name is Seungtaek Chang. I am solution manager at Keysight Technologies. My solution is SA8710A automotive cybersecurity test platform. I have been working at Keysight Technologies since 2001. Thanks for having me today.
Super, thank you for your time, Seungtaek. Let's go directly to the topic then. What is fuzzing about? I'm going to give a quick introduction about fuzzing here. So, what is all this about fuzzing? Fuzzing is a methodology. It's quite old actually. If we think it was the first fuzzer was created in 1988, but fuzz testing got very famous when in the IT industry, especially when Google performed some fuzz testing in Google Chrome and found many bugs. So what is this methodology? Conceptually, fuzz testing is I have a target, a software target in general. In the automotive context is the embedded software. And the fuzzer is another software that sends several random inputs for the target software. The goal is to find hidden bugs. The goal is to create several test cases that will stimulate the software target to find bugs. So this is what fuzzing is about. And there are several types of fuzzers available today. The most common ones are protocol fuzzing, where these inputs are sent through the communication protocol that can be Ethernet, Wi-Fi, Bluetooth. In the case of the automotive industry, are very common CAN communication, automotive Ethernet, and also J1939, for instance, for commercial vehicle. There are different ways customers can do fuzzing. Customers can, for instance, develop their own in-house fuzzer. Many customers do this. There are open source fuzzers that customer can leverage. Also, we are going to talk about this. What are the pros and cons of these tools? But in-house, open source, there are tools in the market like Fuzz, like the solution Seungtaek is also going to tell. The customers can buy a tool to perform fuzzer. And also there is the solution. There are solutions with the fuzzer included. And these many options, they offer different benefits. So those are more or less the fuzzers that exist. So source code fuzzing, protocol fuzzing, and different ways customers can use these tools. Now, one of the questions is, what are the motivation about why customers are actually doing fuzzing? Why this is important? And yeah, Seungtaek, do you want to comment a bit on this?
Sure. I will talk more about the regulation and motivation. For the regulation part, which is based on UNR 155 and 156, UNECE mandated for new vehicles in July 2022 and also mandated for existing models in July this year. So with that, most of vehicle OEM and Tier 1 and Tier 2 company, they need to implement cybersecurity management system and need to get a cybersecurity type approval. And another motivation is since automotive industry moving towards self-driving vehicle and increasing system complexity, vehicles are transforming into interconnected electronic components and software networks, presenting significant security challenges. So that's the most of regulation and motivation part.
Super. Yeah, the regulation is increasing and is changing, as you said. So it's nice to hear this motivation.
Marcos, in your experience, what are some of the challenges customers face when they try to implement fuzzing on their own or use multiple fuzzing tools?
That's a good question. Fuzzing looks simple, but the implementation of fuzzing can show some challenges. What I have seen in the industry, and I listened from customers, they basically have some challenges when they decide to perform fuzzing. One of these challenges, for instance, is to choose a fuzz testing method. So it's very common when talking to customers, they are faced with the following questions. Should I use protocol fuzzing? Should I use source code fuzzing? Or should I use any other method, a hybrid fuzzing, and etc.? This per se is a challenge. Once the method is chosen, then customers they need to understand what is the best tool. As I mentioned before, there are several tools. No? They can develop a tool in-house, use an open source, buy a tool from the market, use a tool with a more comprehensive solution. This is also a challenge from the customer. Once the customer has chosen a method and a tool, then I also have heard quite commonly that deploying the test strategy with fuzzing across the globe, this is a challenge also, because not many users and customers they know about fuzzing, but they need to run the fuzz test. So in this case, you may have challenge with reporting and etc. And one last challenge that we are going to talk more in the future, in a couple of minutes, is what do customers do after running the test? Because if you run the first testing, then you have findings, you have bugs, but then there is a whole thing that needs to be done later. And this currently, in my opinion, is one of the biggest challenges. Seungtaek, this is what I have seen from customers. What do you think? Does it make sense for you? Is this what you also have
Yeah,
heard?
sure, it does perfectly make sense. And also, we can see also most of the testing is not done for once. Engineers need to verify fuzz testing and pad testing iteratively. So once they find a new vulnerability, they need to update their software that needs to be applied through a cybersecurity management system. So this process is iterative and takes a lot of time. So those kind of iterative, many repeating and testing, and also it takes a lot of time.
That's a very good point, nah? Because we hear in the automotive industry the time for deploying a new software needs to be shorter and shorter, right? In the past, customers deploy a car, and then if they would deploy a new software, they would be just in the new version of the car or with a recall. But what you're saying, Seungtaek, what you're saying is that now as the software are more released, the iterative tests are more and more. Is this what you said?
Yes, correct.
Yeah, that's really interesting. So test automation, fast analysis, they are all needed. Super. That's interesting. Thanks for your comment. Yeah, the automotive industry is full of challenges. And what I also would like to comment here is what are the solutions for these challenges? Uh, and this is what we have seen many people, many users in the industry. And I would like also to talk about how customers are solving these challenges. So one challenge that I said is choosing a test method. uh, and I mentioned that there is source code fuzzing and protocol fuzzing. The question that we could spend really hours discussing this is which one to choose, source code or protocol fuzzing. Here's my personal opinion. Source code fuzzing, basically, you perform fuzzing in a software in a piece of software and you mutate all the inputs on the software, and you have instrumentation to check if the software failed or not, or if you have a buffer overflow, and etc. This is good. You have a lot of detailed information, but the trade-off is that you need to instrument to make an instrumentation in your software, and then you need to do a lot of engineering in changing the code to perform source code fuzzing. So the other method, there is protocol fuzzing, is more in the direction of black box. So customers send inputs through the communication protocol, so it's faster. But checking if the ECU or if the software crashed is a bit more challenging because it's a black box. So what I have seen the customers make how the customers solve this. In general, if the customers need to do a faster setup and they don't have access to the source code, then they perform protocol fuzzing. If they have access to the source code, then they perform both source code fuzzing and protocol fuzzing, if they have time and resources for this. The other challenge that I mentioned was deploy in a global scale. So how customers solve this? In general, they look for a fuzzer that is easier to use. So the easier to use and the easier to analyze the report, the better to deploy in a global scale. And when there is available training and available content, customers also can leverage this training and content for this. And when to decide a tool, because after customers deciding which method to use, source code fuzzing or protocol fuzzing, and decide how they are going to deploy in a global scale, how to choose a tool. There are pros and cons in all the options that I said. For instance, developing an in-house fuzzer is possible. Customers can highly customize it, but then takes more time, takes engineering time. Open source fuzzers can be an option. Customers have a starting point, so this is good. On the other hand, customers also need to include some engineering for the customization and needs to be fully liable for the results of the fuzzer. So this is also the trade-off. Tools available in the market. The benefit from the customers is that they can have quickly in their hands a tool that is already validated with features from the market. The other side is that they need to pay upfront, in general in a license, a perpetual or subscription license. So those are how customers will solve this problem is to understanding the pros and cons of considering in-house, open source, and tools in the market, and taking a decision. Now, what is also interesting is that many customers, they may have the full solution, a solution that is not only fuzzing, but also other tests around. And Seungtaek, you are very good on this, on the solution oriented. Do you want to mention how customers are solving the problem?
Yeah, as you mentioned before, some customers are focusing on complete regulation fulfillment using the whole integrated cybersecurity test solution. They might use a basic toolset for automotive cybersecurity, such as IoT security assessment software, and combine the software and hardware support with the cybersecurity full test platform. So we can talk more about those kind of full test platform which can provided by Keysight Technologies. So now we can move on to what happens after the test. What are some challenges that are not fully solved? Marcos, can you talk more about that?
Yeah, yeah, sure. Yeah, when we think about all these methods, can be individual tools or the solution as you talked, with more set of tools to do the whole certification. All those customers, regardless of the solution, they have, on my view, two big challenges. One of the challenges is debugging and identifying false positives. because what is happening is that once the customer perform the fuzz testing, then some analysis needs to be done afterwards. Let's say the fuzz has a finding. The fuzz software detected some misfunction. The question is, why this happened? And is this really a bug or this is a false positive? This is a challenge. I have been seeing customers spending a lot of time in this post-test challenging. And the other challenge that is quite interesting that in the beginning, it didn't call my attention, but I learned is real, is the reporting. Now, the reporting of the results is quite challenging also. Yeah. I don't know. Have you also seen these challenges, Seungtaek, with the reporting also?
Yeah, sure. Reporting part, Keysight SA8710A cybersecurity test platform provides a more formal UNR 155 test report that can be modified into customer format. And also it can be generated with PDF and Word format. And it also easily managed by a pathway lab operation management software for audit preparation. So customer can easily managing those kind of test result and audit preparation within the tools.
Okay. And and Seungtaek, in your solution that you mentioned, it, when customers go for the type approval, does the reporting part also help them to go faster to this process?
Yes, sure. So we can manage it one by one. Or also we can categorize the interface type, and also we can categorize by some testing method and interface type and hardware version and module and so on. So you can easily managing those kind of test result and test requirement and test goal and so on. That can be managed by a whole software platform.
Okay. That's really nice. We have seen this is as an issue from the customers, as I said, in the post test challenges, as I said, and it's really interesting to see that you have the solution. And and I would like to also take the time here to announce something in this podcast. As we have seen, there are different ways of doing fuzz testing, and customers can do individually with one fuzzer tool for one protocol, or customers may need a solution. And because we saw this in the market, these different needs, I would like to announce that Keysight and ETAS started a collaboration in this area to serve all the customers. Now, so basically, ETAS has the one component solution that is the product called Sarcofus, and Keysight has the whole solution. And then you are having a partnership to bring all together to the market for you, customer that may need it, may need to use it. And then I would like to invite you, Seungtaek, to talk a bit about the solution from the Keysight side.
Sure. Thanks for the explanation. With this partnership, Keysight Solution implementing a test automation for canvas fuzzing, which is provided by ETAS Cyclefuzz. And also, Keysight Solution validate the robustness of your ECU, TCU, and sub-component, and the entire car against the cyber attacks from the hardware level through all layers of the OSI stack. And also, customer can run the automated cybersecurity requirement verification through various communication technologies using the Keysight threat database. So it is a good partnership within our automotive cybersecurity test platform. And ETAS Cyclefuzz canvas fuzzing tool is very important to testing canvas fuzzing.
Yeah, that's really nice. I'm personally quite excited about this partnership, Seungtaek, because I think we can bring the whole comprehensive solution to the market and leverage the company's potential to, in the end, accelerate what we need to bring to our customers that are faster, further, faster analysis, compatibility and the data curated already in the report in a format that will accelerate the type approval. And that's the message we wanted to bring for you today that is listening to us. Then I go towards here to the end of our podcast. It's interesting to talk to you, Seungtaek. Thank you very much for your insights on the solution. And I would like just also to announce that we are gonna record a webinar soon to show the solution that Seungtaek has talked now. We are gonna make a demonstration this webinar, and it's gonna be in October. So cool. Thank you very much for the explanation, Seungtaek.
Yeah, thank you for having me, Marcos.
Okay, then thanks for joining us in this podcast chapter. And please feel free to join the other chapters that we are recording frequently here about several other interesting topics.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.